what is binomial theorem? We'll first discuss what is a binomial. Is a polynomial that is the sum of two terms. So for example, 5x plus 5y or x squared minus 3x, anything two terms called binomial. Binomial theorem describes the algebraic expansion of a powers of a binomial. So things like this want to expand these expressions. Okay, this topic falls into two major parts. So after we expand this, we want to find a specific term, finding a specific coefficient or the greatest coefficient. And then the second part of the course is to prove identities involving this, which you will learn later. All right, let's move on to the first part. Let's start expanding this, see if we find some formulas. So we'll do the first one. Anything to power 0 is 1. And what's the next one? Anything to power 1 is itself. Next one you will learn from year 9. This is the perfect square formula. And the only thing you haven't learned is how to expand cube. You may have learned that in year 11, but let's revise this again. Okay, so we did a plus b, and then a plus b squared, right? That's the first step. And then what's a plus b squared? It's a perfect square, a squared plus 2ab plus b squared. Yes? And then you expand the second bit, right? So you get a cubed plus 2a squared b plus ab squared plus a squared b plus 2ab squared plus b cubed. All right, take a look. Any like terms? You'll find there are some like terms. The 2a squared b matches with a squared b, which is 3a squared b. And the other one is ab squared plus 2ab squared is 3ab squared. And then finally, b cubed at the end. Okay, so we expanded it. So please see that. Now, what's a term? A term, for example, this is a term, 3a squared b. The coefficient of the term is the number in front, write 3. Okay? All right. Okay, in this case, there are 4 terms here. Now, we're going to introduce the Pascal's triangle, which you've probably seen it the first time, or you've probably seen it before. So your first step is to write 1 on the first cell. And the next row, just write 1, 1. Nothing special. The next one, you go like this. The second row, the third row, you write 1 first, starts with 1, and you add these two. 1 plus 1, 2. And the next one, there's nothing to add, 1. Right? 1, 2, 1. Right? Okay. Let me rub this off, plus. Okay, how do you do the next row? Watch. 1 first, always starts with 1. 1 plus 2, 3. 2 plus 1, 3. 1 plus, there's nothing to add, just finish it with 1. Yep. Okay, let's start the next row. Start with 1. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. And nothing to add, put 1. And then keep going until you get to the row 10. All right, have a try. All right, practice this. All right, take your time to add it. Use a calculator where necessary. So it starts with 1, 5, 10, 10, 5, 1. 0 plus, they're plussing. Yeah, not time. There's nothing to add, so you just finish with 1, start with 1. Okay, start with 1. 1 plus 5, 6. 5 plus 10, 15. 20, 15, 6, 1. Yep. 1, 7, 21, 35, 35 again, 21. You will notice soon that they're actually symmetrical, isn't it? Yep. Okay. Starts with 1. Next is 8, 28. And then things get a bit harder. 56, 70, 56. So basically increases and decreases. Agree? We're almost there. 1, 9, 36. And then this gets a bit hard. 28 plus 56. 84. All right. Next one. Right, it's on the table. Actually, it's not on the table. There you go. All right. Next one, keep adding. 56 plus 70. What would that be? 126. Okay. And then 84 again. 36. Is that right? No. I missed something. Oh, 126 twice. 84, 36, 9, and then 1. Alright, and one more row. Thank you. I'll just copy this. 1, 10, 45, 120, 210, 252. If you did it all yourself, very good. 10 and then 1. Okay, good. So after you do this, you start to see some pattern, but not a lot of pattern, just some pattern. All right, so you will see that for the Pascal's triangle, the leading and the last coefficients are both 1. They always start with 1, finish with 1. Now, why do I do this? Can you see that the expansion we did matches with the numbers on the Pascal's triangle, right? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Can you see it matches here? With the coefficient of the second and the second last term equals to the powers of the expansion. So basically this one 3, the first, second number and the second last number always correspond to the powers there. Okay? The coefficients are symmetrical. Subsequent lines of the Pascal's triangle are generated by beginning with 1, adding the two numbers in the line above, then finishing with 1. And then we note that how many terms does a plus b to the power n has when you expand it? If you expand 3, you have 4 terms, isn't it? 1 more than the number of powers, so this will have n plus 1 terms. And you will also notice that the powers of the first term step down by 1, the powers of the last term step up by 1. So look at this, start with a cubed, and then a cubed, the powers start to decrease each step, and the powers of b increases as you go on, right? And then the sum of the powers in each term is n, the power of the expansion, and okay, so that's all there is. And one last property, if you add the coefficients along the row, see what numbers you get. What if you add the two numbers? What do you get? Let's try to add the numbers. 1 plus 1 is 2. 1 plus 2 plus 1 is 4. 1 plus 3 plus 1. What do you get? You get 8, right? What are these numbers? These are all powers of 2, right? Okay. All right, good. All right, so we'll look at that property later on. So let's apply this Pascal's triangle on the next page. So let's go to the next page. Let's expand this. Now, hopefully you got your exercise booklet. There's the Pascal triangle there. Now, which row do you look at to expand this? You look the 5th one. Okay, let's look at the 5th one. The numbers are 1, 5, 10, 10, 5, 1, right? So how do you do? You start with a to the power 5, and the number in front is 1. The next number is 5. The a to the power 5 becomes a to the power 4, right? A to the power 4, b. So the powers of a goes down, the powers of b goes up, plus the next one is 10, and you go a to the power of 3, b squared, And the next number is, so these numbers are the coefficients. So you get the coefficient, 10 again, and you get a squared b cubed. Get it? The powers of a goes down, and the next one is 5. So right, plus 5. You get a b to the power 4, and finally 1 b to the power 5. Get the idea? That's the expansion. So it's slow at first, but it gets quicker later. So you get 5a 4b. I'm just writing it again. Okay, good. Can you try the next one? What's the next one say? Oh, I left a lot of space. Oh, the next one is a plus b to the power 6. Can you try that? Try this one. Expand this. Look at the Pascal's triangle. Give you a couple of minutes. Have a try. And then you find it's pretty easy. Yeah. Tomorrow. All right. All right, let's start this. A to the power of 6, and then 6a to the power 5b, 15a to the power 4b squared, plus 20a cubed b cubed, plus 15a squared b4, plus 6a b to the power 5, plus b to the power 6. All got that? Okay, now we can expand this. The next question, how do we expand? What if there's a negative? Will this work the same? Let's experiment with this. Let's expand this. So we get 1, a minus b, expansion from year 10, year 9, the perfect square formula. And the cube one, let's see if it works. So you get a minus b squared. See if the negative have any impact on the expression. All right, so let's expand. So you get a cubed minus 2a squared b plus ab squared minus a squared b plus 2ab squared minus b cubed. Right? Collect like terms, you get this. You get these two are like terms. So negative 3a squared b. These two are like terms. And then lastly, this is like that. So you notice that it still works, the Pascal's triangle. You get the same numbers as before. Let's look at this more carefully. The 1, 1, except you get some negative sign at certain places. We just need to make sure put the negative sign in the right place, right? So you get the triangle 1, 1, 1, 2, 1, 1, 3, 3, 1, but except some of these are negative, right? So it looks like it's negative for every second term, right? Every second term you get negative, but we don't need to modify the Pascal's triangle. We just need to remember where to put the negative. Now, why does it only occur in the second term? It only occurs in the second term because the powers of b is odd, right? Whenever the powers of b is odd, you get negative. Get the idea? So that can be explained very easily if I write this as this, okay? So you can write a minus b cubed as a plus negative b, right? So when you expand it, you can write a cubed plus 3a squared negative b plus 3a negative b squared minus 3 plus negative b cubed. So you can still use the previous formula but replace the b by negative b. So that's why every time it's an odd power, you get negative, right? But when it's an even power, you get positive. And when it's an odd power again, you get negative. So that's how this works. Okay, have a think. We're going to do more practice questions. All right, come here. All right, Marco. Sorry. All right. Okay. All right, let's do some examples. So we're going to expand more binomial expansions. So we'll go to the next page. Hopefully you're all ready. Let's use the formula now. It's very easy. Okay, let's try this one. So 3 is, just remember, 1, 3, 3, 1. So you go like this. X cubed, that's the first term. You start with the highest power. Plus 3x squared times 1. Plus 3x 1 square plus 1 cube, right? Which simplifies to be x cubed plus 3x squared plus 3x plus 1. Yep. All right, let's try the next one. How does the next one work? The 5, just remember the Pascal's triangle. 1, 5, is that 1, 5, 10, 10, 5, 1. These are the coefficients. So you write x to the power of 5. And then now, if it's minus, just remember you alternate the signs. So you just go minus x 5x to the power 4 plus 10x cubed minus 10x squared plus 5x minus 1, like that. All right, hopefully you're done. Next one, you go 1, 3, 3, 1. Okay, now you can actually generate this on a calculator. 1, 3, 3, 1. Let me see if I remember. So if you just go 11 cubed, does it work? 1, 3, 3, 1. So you go 11 to the power 4. Would it work with that? 1, 4, 6, 4, 1. Yep. So work, but it has limitation. Once it goes 5 digits, 2 digits doesn't work. Yeah. So it goes up, works up to 4. Okay. Actually, if you go 101, would it work to the power of 5? No, I'll just give you very big. Okay. All right. So just draw your own Pascal's triangle. Okay. All right. Next one, you go 1 cube plus 3 1 square x plus 3 1 x squared plus x cubed. Notice the order has changed. Right? Notice the order has changed. The difference between 1 plus x cubed and x plus 1 cubed. Right? You get the same thing. They're actually the same, but you write it in different order. Because the first one, the x term starts. The other one, the 1 starts. Get the idea? So keep in the habit of whatever it starts with the highest power. Okay, whatever it's the second, start off with the lowest power, but ends up with the highest power at the end. All right, try the next one. 1 minus x to the power 5. So you go 1 minus 5x4. No, not 5x4, 5x. And then what's the next one? 5 and then 10 x squared minus 10 x cubed plus 5x4 and then minus x to the power 5. Notice that these two are a bit different because x minus 1 to the power 5 is different from 1 minus x to the power 5. All right, okay. All right, once we do this, we'll do more expansion. Okay, good. You're ready? Next one. expand this. So you can expand some harder ones. So just remember is this one you go 14641. Let's start. 2a to the power 4 plus 4 times 2a cubed plus, notice that when it's 1, I just ignore it because it doesn't do anything. And then you go 6 2a squared plus 4 2a and finally 1. So the powers of a decreases, the powers of 1 increases but doesn't do anything. Okay, let's simplify. Do it step by step. 2 to the power 4 is 16. And this one you do need a calculator. 4 times 8, or you can do it without. 32a cubed. 4 times 6, 24a squared. 4 times 2 is 6 at 8. Okay, good. Try the next one. And then you have to state the coefficient of a cubed. So what would you write? Coefficient of a cubed is 32. Right? Try the next one. So once you know the rule, Pascal's triangle, you can expand any binomial expression. Okay? Right, we're on page 5. Okay, let's start to do this. Okay, so we'll get 3x cubed. What's the next one? 1313, 3x squared, 2y plus 3x, 2y squared plus 2y cubed. Right? So the numbers are the coefficients 3, 3, 1. These are from the Pascal's triangle. And just work out. Right, let's continue. What do you get? You get 27x cubed plus 27x squared, double it 54. Y plus 4 times 9, 36 plus 8y cubed. Okay? I might have done it wrong. Hang on. 2 times 27. Because that's 3 squared is 9. 9 times 3 is 27. 27 times 2 is 54. Okay, done. Alright, next page. Okay, continue. We'll do a harder one. Try this one. So 2 over x power 4. 4. So 14641. Plus 4 6. 2 over x cubed squared, x squared plus, what's the next one? 4, 2 over x, x cubed plus x power of 4. Well, next page. So 4641. So you simplify each. So how do we simplify? You just raise it to power 4. So you get 16x power 4. That will be 32 x cubed times x on top plus 4 times 6, 24 x squared on top plus 8x cubed over x plus x power 4. Okay, now make sure you simplify. So if you simplify that, that will be this. You get x squared, that get cancelled, that you get squared. So your final answer will be 16 over x power 4 plus 32 over x squared plus 24 plus 8x squared plus x power 4. And then you can answer the question. Okay, so you have to find two things. Okay, now you have to find two things. Find the coefficient of x power negative 2. Which one's x power negative 2? This one here, 32. So coefficient of x power negative 2 is 32. And what's the second thing they ask you to do? Find the term independent of x. That's a very important terminology. Term independent of x is the constant term because there's no x in there. Which one's the constant term? 24, right? So write term independent of x is 24. Right, done. Right. We continue to expand. Alright, let's look at D when you're ready. Okay, let's continue. So expand this, so you get x squared, so you get x squared power of 5 minus 1, 5, 10, is that 1, 5, 10, 10, 5, 1. Okay, good. So you go 5 x squared cubed 4y plus 10 x squared cubed y squared minus 10 x squared y cubed plus 5 x squared y4 and then minus y power 5. And if you just simplify, that will be x power 10 minus 5x power 8 plus 10x power 6 minus 10x power 4 and then plus 5x squared y power 4 and then minus y power 5. And basically the fifth term, this is the first, the fifth term will be second, third, fourth, fifth. That's the fifth term. Fifth term equal to 5x squared y power 4. And I'll leave the part E for you to try out. We'll just skip that. We'll do some expansion involving surds. And then there's the harder question towards the end. Right. Okay, good. Let's try the next one. E, I'm going to skip. How about this one? You have to expand surds as well. That will be useful. Let's expand this. So you get 1 cubed plus 3, 1 squared root 3 plus 3, 1 root 3 squared plus root 3 cubed. Okay, now you have to simplify. Will be 1 plus 3 root 3 plus 3 times 3. Now root 3 cubed is root 3 cubed is root 3 squared times root 3, which is 3 root 3. Okay, and you collect like terms, so these are like terms, 6 root 3, 9 plus 1 is 10, right? So therefore, you can find out what A is. So A must be 10, B must be 6. So it's pretty easy, okay? All right. I'll leave the next one for you to try by yourself. All right, so try by yourself. Sorry, I put it back in here if you haven't got it. Okay, all got it? Okay, now the next page, just try by yourself. Try by yourself. Try by yourself. Okay, we'll do two more harder questions. Then you get some chance to do the homework today before we finish the lesson. Okay, let's do this. You can get some harder one. Find the coefficient of x cubed in this. Okay, let's do that. So what would you do? You're going to expand. Expand this. So you go x power of 4, we're on page 8, plus, and then minus, what do you get? So it'll be 14641, 4x squared cube 3, and then plus 6 x squared square 3 square minus 4x squared 3 cube plus 3 to the power 4. Like that. Let's simplify. X power of 8 minus 12x power 6 plus 9 times 6 is 54 x power 4 minus 27 times 4 double twice 54, 108 x squared plus 81. Alright, and then just keep expanding. So you go to, so you just expand. Then you start going through this, etc. So you go 2 times the first one, 2x 8 minus 24x power 6 plus 108 x power 4 minus 316 x squared plus 6162 minus 5 x power of 9 plus 60 x power 7 minus 54 times 5. 54 times 5, you get 270. 270 x power 5 minus plus 540 x cubed minus 405. Very long. Now collect like terms. Oh, there's no like terms, fortunately. Good. Now we have to answer the question. Find the coefficient of x cubed. What's the coefficient of x cubed? 540, isn't it? Coefficient of x cubed is 540. Can anyone see a shorter way without expanding everything? What's a faster way? How do I get x cubed? You can actually stop over here, right? How do I get x cubed? The only way to get x cubed is times these two together, right? So do 5 times 108, that gives you that, without doing all the steps. Daddy, can you try the next one using the same method? Try the next one. So this one, you can get by doing -5 times -108, which is equal to 540. All right, try the next one. Okay, good. So we'll try the next one. Let's try that. Find the coefficient x power 5. So you get x squared minus 3x plus 11. So you go 4 cubed plus 3, 4 square, x cubed plus 3, 4 times x square, or x cubed square, plus x power of cube. Okay, let's simplify this a little bit. So you get 4 cubed is 64, plus 16 times 3 is 48, x cubed, plus 12 x power of 6 plus x power 9. Now, you don't have to expand everything. As you see earlier, you just have to selectively to get x power 5. How do I get x power 5? X squared times x cubed. I think that's the only way, right? So therefore, coefficient of x power 5 is 48. times 1, which is 48. Right, good. Okay, so you start the exercise today, exercise 5A from the chemistry booklet I just gave you. Alright, done. Giving you the